This is section 6.3, area of a triangle. Our objective today is to find the area of a triangle and relate side lengths and area. The base of a triangle is any side of the triangle. The height is the length of the perpendicular segment from a vertex to the base opposite the vertex, or to an extension of the base. Basically, a segment perpendicular to the base from the opposite corner. So the base and the height just have to form that 90-degree angle. So how are triangles and parallelograms related? Notice that I can take this triangle and it has the exact same base length and height as this rectangle. Notice there are just two extra sections of my rectangle. This triangle here and this one over here. Well, if I take those two triangles and I rotate them around, there we go. Notice that they perfectly fill up the original triangle, which means two of that original triangle would fit into one rectangle. So the area of a triangle is 1/2 times the base times the height, as long as the base and height are perpendicular. Remember that right angle. We're going to find each area. So for our first problem, our base and our height have to make a 90-degree angle. Here it is right here. So we take 1/2 times the base, which is 8, times the height, which is 5. 1/2 of 8 is 4. 4 times 5 is 20. And we're working in square feet. For the second one, my base is 9. My height is 12. So I take 1/2 times 9 times 12. And remember, you can do multiplication in any order. So 1/2 times 12 is 6. 6 times 9 is 54. And this is square meters. Realize that this empty piece right there is just showing that the height made a right angle there. It's not part of our triangle. It doesn't matter to our problem. So try these two. All right, for the first one, the base is 36, the height is 12. So to find the area, we do 1/2 times 36 times 12, and we get 216 square meters. For the second one, the base is 16, the height is 6. Remember, this 4 is really nothing to us. So we do 1/2 times 16 times 6, and we get 48 square centimeters. All right, a quilt has a design of small and large triangles. A small triangle is shown here, and a large triangle has the same shape, but the sides are twice as long as the sides in the small triangle. About how many times larger is the area of the large triangle than the area of the small triangle? There is a reason we're talking about this. So let's first just calculate the area of this small triangle. Its area is 1/2 times 3.4 times 3.1, because this would be the right angle right there. So that area is 5.27 square inches. Now in the larger triangle, let me draw us a little picture here. There's an L for larger. Everything is doubled. So this side is 6.2, this is 6.8, and this side would be 8.94. Just kidding. 9.4. The area would be 1/2 times 6.2 times 6.8, which is 21.08 square inches. Notice that this area is not just double. It's more like 5 to get to 21 is about 4 times larger. When I double side lengths, my area is going to get more like 4 times bigger. And now we are going to find the length of the missing side of this triangle. Let's call it x. Well, we know that the area is 54. And we know that area is 1/2 times base times height. This 15 is not the base or the height, so we don't care about it right now. Let's plug in what we know. 54 is the area. 1/2, the base is 12, and the height is x. Well, 1/2 times 12 is 6. Divide both sides by 6, and x equals 9 centimeters. Here's your assignment.